This is a module for investigation 4 about partials and nth unit growth factors. So the x value could be increased by not 1 unit, okay? It could be 2 units or 3 units or 4 units, and then also half units and 1/4 units too. So that's what we're going to think about. All right, but let's start with the number 2 first. You are given the 4, 38, 7, and 50. So you are given only this and this and this and this. The two order pairs for the exponential growth functions. Your classmate noticed that the difference in the output is 12 and the input changed by 3. So they're talking about this from here to here. The input changed by 3, but output changed by 12. So the creates the table showed some additional order pair. So explain how you know that the two additional order pair bolded cannot be accurate even though we don't have a function formula or the graph for the relationship. So there, we try to make that as exponential growth functions, not the linear, but I think this looks like a linear to me because the x value is increasing by 1 and then y value is also increasing by, I think, 4. Isn't it 4? Do you see 4? So when x increasing by 1 and the y is increased by constant rate of change, this must be the linear, not the exponential. So it doesn't work with f of x equal to a times b to the x power. So they want to actually change the middle number to be an exponential form, okay? So what they do was they try to put it as a table, right? Which could be the exponential. So x and y. And there's what two number you should put in to get the exponential. So 4, 38, and then 7 and 50 is a given, okay? So x is increasing by 1 anyway, but the y value, it can be the 42 and 46, it could be exponential function. So we try to change that. So how do you figure it out? So first of all, I want to see how much has been increases from the 50 to 48. So 50 to 38 to divide it. Okay. But this is actually the 3 unit, the whatever the, when I say x here, but this is going to be the 3 unit growth factor. Okay. This is a 3 unit growth factor. Why? Because x is actually has been increased by 3. So I try to change it to the 1 unit growth factor. So in order to be a 1 unit growth factor, I just need to the x divided by 3. And then this becomes the 1 unit growth factor. So what I do is it's been increased by 1. So you got the 0 as that 4, right? 38, right? And then what I do is whatever the previous number, okay, whatever the previous number, which is 38, and then I'm gonna multiply by 50 over 38 as a 1 unit growth factor instead of the 3 units, okay? Then when you do that, you get the 41.6. Now, in order to get the next one, so you're using the 41.6, and then you use another 1 unit growth factor, which is 1/3 power, and then you get the 45.6. So it's a little bit different though, okay? There's not much big deal, okay? Which is there's a 42, but now I have a 41.6. Now 46, I have a 45.6. And then if you do with the form, which is 50 should be 45.6 of 50 over 38, 1/3, and then you get the very closer number to the 50, okay? Yeah, so this two number you should have put instead of the 42 and the 46, okay? And then now it's not going to be linear because 41 minus 6, 41 minus 41.6 minus 38, which is going to be 3.6, and then 41.6, 45 minus 6, it be the 4. So yeah, it's not going to be the same difference between the two y values, okay? All right, let's do the number 4. Okay, so in the investigation 4, I will do 2, 4, A through E, and then the number 8, okay? So I need to do number 4. So in number 4, when the COVID-19 pandemic spread across the United States, many states implemented the social distancing measures and stays-at-home orders order to slow its spread. After a few weeks, however, the many states began to be open business and relaxed these measures. In many states, this caused on the increases in infection rate. After relaxing stay-at-home order, the social distancing measures, the number of the total COVID-19 cases in Arizona increases from the 16,891 on May 23rd, 2020, becomes 31,264 on June 11, 2020, in period of 20 days. For these exercises, assume that the growth in the total case follow an exponential model. So if this growth pattern continue, how many total cases would Arizona have in 20 days after the June 11th? So which is going to be the June, is it the June has a 30? So it has to be the June doesn't have a 31st, right? So it's going to be the July, right? So okay, so yes, so let's try. So the growth, this is a growing, right? So growth rate is 31,264 over 16,891. It is 20-day growth factor. So you're looking for the number of the COVID positive cases, okay, COVID-19 positive cases in 20 days later after the June 11th, right? So the June 11th was 31,264, and then if you multiply 312.64, 16,891, and becomes we got 57,868 cases if you use that, okay? But that's after the 20 days, okay? And then B, by what percent did the total number of the Arizona COVID-19 cases increases during this 20 days period, okay? So which means you just need to put out as 31,264 over 16,891, which is 1.851, and then this is the increase, right? So this is going to be 1,851%. Wow, that's a lot, right? No, sorry, what am I doing? 181, right? 185.1%, right? So in order to find out the percent increase, we're going to do the 185.1 subtract the 100, which is 85.1% increase. And then C, assume an exponential growth model. What was the 1-day growth factor and the 1-day percent change? Okay, so 1-day growth factor means okay, so you can just use a 31,264 divided by 16,891, but that's the 1.851, right? But this is actually the 20 days, right? So when I say T, it's gonna be the 20-day growth factor. So in order to find the 1 day, so which is I don't need to use a variable this. Okay, so let's say that's gonna be the 20 day. Then 1 means a 20 day, but change that as here. But we try to change to the 1 day. So this is the 20 days. Okay, let's put T. That'll be better. Okay. And then we can just drop to this one. Okay, so what I do is change to, so this is a T. Okay, so which means I'm gonna use a 1.851. Okay. And then instead of the 20 days growth factor, I want to change the 1 day growth factor, okay? Which means you can just t over 20. But we are using in the 1 day, so it's percentage here. So we can just say 1.851 over 1 over 20, which is the same as 1.031. So 1.031 is 103.1%. So which means 103.1 subtract 100, you get the 3.1% increase each day. And then D, assume the exponential growth model. What was the 10 days growth factor, 10 days percent change for the total number of the COVID-19 case in Arizona during this period? What about the 30-day growth factor, 30 days percent change, so on, right? So the 10-day growth factor, so once we have the 20 days, and then so we have a 1.851, right? And then we want to change to the 10 days, which the 10 days half of the 20, right? So you can say 1 over 2, which come out as 1.360, which means percent change is you gotta do 136%, subtract 100%, which is 36% change. 30 days, which is you have to put the ratio, so the 30 is actually the 1.5, so you can just put the 1.851, but 30 day is the 1.5 times more than 20, right? So 30 over 2, right? So 30 over 20, so you can just put the 30 over 20 if you want. Okay, 30 over 20, because so you can just put that as this one is actually the 10 over 20, isn't it? And then 1 over 20 for the 1 day, right? Yeah. And then you get the 1.851 as 1.5, which is about 2.518. And then for the percent change, it becomes 251.8%. Subtract 100%, you get the 151.8%. That's a percent change, but still increases, right? And then E, define the function f that expresses the total number of the Arizona COVID-19 cases during the period in terms of the numbers of the days since May 23rd, 2020. So we are looking for the as a formula, right? So since f of t, then what I want to do is I try to make that as a one day growth factor, okay? So starting from the 16,891 as initial value, and then we try to make that as a 1.851, but I want to say 1 over 20, okay? Because I try to make that 20 days, which is 1 day out of the 20, right? And then becomes as a t, okay? And then we change the t as every day, okay? So 16,891, and then if you put it as 1.031 to the tth power, which is, we already had it here for the 1 day. Did we? Yeah, 1 day right here. Yeah, we already found it from here. Right here. Okay, so this is what you need to use for the 1 day. And then f is, you just need to plug it in. Now, how about the 4 days after? How about 13 days after? How about the 26 days after? All right, let's look at the number 8. After taking medicine, your body begin to break it down and remove it according to a pattern of the exponential decay. This time it's decreasing. Suppose you take the 500 milligram of the ibuprofen, and after 5 hours, only 110 milligram is left in your system. So after 5 hours, what percent of the 500 milligram does remain in your body? How much ibuprofen in milligram remains in your body? Okay, so what I do is I need to use 110 over 500 right here. So 110 and divide by 500, I got 0.22. Okay, so this is then change the percentage 22%. So 22% is remains, and then the how much remains? 110 milligrams. Okay, that remains. And B, define a function f express the amount of the ibuprofen in milligrams. B, presents after n 5-hour time interval since the taking the medications. Okay, so the function is the f, and then of the n, which is starting from the 500, but for the remaining weight is 0.22 for the n, which is n is the every 5 hours. Okay, but in C, define the function g express the amount of the ibuprofen in milligram present t is hours after the take the medication, not the every 5 hours, but it's every hours. Okay, so I want to say g of t is 500 still stay the same, but instead of the 0.22 for the every 5 hour, I want to change the every hour, so I 1/5 to the tth power here. Okay, and then you can just simplify if you need it. Okay, and then once you got the C, and then D is how much the ibuprofen remains in your body 3 hours after taking. So very nice to have it. Okay, so you can just have a G of 3, which is 500, and you got 0.22 to the 1/5 to the third power, which is about 201.569 milligrams. Stays the same, stays in body. And then after 12 hours is 500 and 0.22, 5/3 to the 12th power becomes a 13 and 206 milligrams. So how does the change in the amount of the ibuprofen remains changed as the number of the hour elapsed increases? So as the number of the hour after taking the medicine increases, the magnitude of decreases are less and less for the same changes in time, since we are decreasing by the same percentage of the smaller and smaller. So the change amount that is hours increases as the number of the hours increases. After taking the medication though. And then the amount of ibuprofen remaining change and decreases smaller and smaller. All right, that'll be all for this section. Thank you.